Okay, guys, so welcome back. And for today, for this topic, we will discuss the protozoan parasite, particularly the amoeba. Okay, so protozoan parasites are single celled microscopic parasite under the kingdom Protista, such as amoeba, flagellate, ciliates, sporozoans. So the name protozoa literally means first animals. So protozoa are eukaryotic organisms. So when we say again eukaryotic organisms, they have nucleus and other organelles. Okay, so these eukaryotic organisms exist as structurally and functionally independent individual cells, which means that they are single-celled organisms. However, even if they are single-celled organism, they can exist on their own. Kaya nyo bang mag-exist ng kayo lang? Okay? But for humans and other animals, we are multicellular. Okay? For amoeba, okay, they are single-celled organism, but they can exist in that way. Okay? So protozoa have developed relatively complex subcellular features. So they have membranes, they have nucleus, which enable them to survive the rigors of their environment. Okay, next slide. So we have here an image of the different stages possible for an amoeba. Okay, so we have here, this is a cyst stage. Guys, cyst stage, this is actually the infective stage, or this is the resistant stage for most of the amoeba, particularly the entamoebas. Okay, so this is the resistant stage. Why is it resistant? Because it can survive in adverse environment. Okay, so it can survive in the soil or even at high temperature but not at extreme temperature. Okay, so this is resistant, the stage that is resistant to adverse environment, and this is the infective stage for Entamoeba histolytica. So we have here the flagellated form of Naegleria fowleri or fowleri. So Naegleria fowleri and Acanthamoeba, these are free-living organisms. Okay, so they can exist on their own without needing a host. Unlike for the entamoebas, like for Entamoeba histolytica, it is not a free living. Okay, so it needs a definitive host to complete its life cycle. So this one, okay, so this one is in trophozoite stage. Okay, so trophozoite stage for amoebas, these are their feeding stage. This is the stage that can ingest, okay, or that can ingest nutrients or bacteria. Okay, so next slide. So, guys, don't mind the numbers that I'm placing on this part, on the upper left part of this slide, because these are the indications of the slide number. Okay, so that is for the slide number. So we have the commonly used terms, or not commonly used, or you cannot see it commonly in our discussion, but I may forgot to discuss what are they. So let's define. So we have here the charcote-laden crystals. So charcote-laden crystals are crystallized structures of varying sizes that are found in feces, sputum, and body tissues of those with helminth infestation. Okay, so these charcote-laden crystals, they originate from eosinophils and is found in allergic infections. Okay, so if there are allergic infections or parasitic infections, particularly helminth infestations, okay, or infections, helminth infections, most likely we'll see a charcote-laden crystal in some of the body fluids. So we have chromatin, so it is a nuclear components that stain when appropriate staining materials and techniques are employed. So this part, this is the chromatin. And we can use the chromatin as a differential, as to differentiate the morphologies of the different amoeba, the different entamoebas. Okay, so this is the pseudopod and ingested RBC. For an amoeba which can ingest RBC, only the entamoeba histolytica is capable of ingesting red blood cell because they are only the pathogenic amoeba, okay, that has invasive form. So they are invasive, they can ingest red blood cell, and this is a distinguishing feature in the laboratory diagnosis for the entamoeba histolytica infection. So number 5, so this is slide number 5, contractile vacuoles, organelles. So these are little organs that pump accumulated fluids from protozoa. So protozoa, these are unicellular organisms, to regulate the internal pressure. Going back, again, I should say, cyst. This is a stage of a protozoan that is non-motile, okay? So that is non-motile and is surrounded by protective wall, and that is the stage that is transmitted to new host. That's why, guys, the cyst stage, if you are wondering why is it that for entamoeba and other parasite which have cyst stage, why is it that they can infect human even if we have our stomach acid, which is in fact a protective barrier against bacterial infection, right? But for parasites with infective stage that are cyst, the cyst stage is actually resistant to the stomach acid. That's why they can survive if they are ingested. Okay, so we have here the trophozoite. It has the pseudopods. So for trophozoite stage, unlike the cyst stage, it is motile. Okay, so that is motile. So cytostome, that is a mouth-like opening of certain protozoa, and it is present in Balantidium coli. Take note that Balantidium coli is the only medically important parasite under ciliates. Okay, so nag-iisa siya under ciliates as medically important parasite. So we have here the process of transforming from either cyst to trophozoite or trophozoite to cyst. Okay, so for entamoebas like Entamoeba histolytica, Entamoeba coli, Hartmanni, and Dispar, and other entamoebas, okay, excluding the free-living Naegleria fowleri, okay, they can undergo the process of incestation and excistation. When we say incestation, incest, so this is the process of transforming to become incest, so that is to become a cyst. Magiging cyst siya, incest, okay? On the other hand, when we say existation, okay, so that is the process of becoming a trophozoite, okay? So it is it is the process of becoming a trophozoite from a cyst stage. Kaya nga, exist. Dati siyang cyst form. Okay? So, exist, magiging cyst pa lang po siya. Okay? So, those are the two stages for entamoebas. Okay? Or for amoebas. So the glycogen vacuole, that is similar to starch and will stain with a variety of stains. This is a food storage vacuole found in certain amoeba. That's why it was compared to starch as a storage source of energy. Okay, so we have here, this is a glycogen vacuole, and even this one, glycogen vacuoles. So caryosome, on the other hand, is a body included in the chromatin of the nucleus that usually stains a darker color than the remainder of the nucleus. So we have here, so this is the caryosome. So in this trophozoite that is located at the center of the nucleus. Okay, so this is the nucleus, this is the caryosome. So for pseudopod, there are two main functions served by pseudopod. Of course, that is, they use it for locomotion and for phagocytosis. Okay, so that is the part that phagocytize bacteria or red blood cells that they will use um, and other nutrients that they need to feed themselves. So that is for locomotion and phagocytosis. Pre-cystic form, that is the form. Okay, so a trophocyte stage often found just before complete incestation. Okay, so trophocyte becoming a cyst, so we have there the pre-cyst before the cyst stage. Okay, so that is before the cyst stage. So pseudopod means false foot, okay, and is a temporary extension or protrusion of an amoeba. And again, what are the two main functions of the pseudopod of the amoeba? First is okay, that is their organ for locomotion. So they use it to move from a place to another. And aside from that, that is for phagocytosis. Okay, next slide. So trophocyte, again, the trophocyte is the feeding stage. Okay, so that is the feeding stage. It also multiplies and grows within the host. Okay, so guys, take note in laboratory diagnosis. Most of the time, if you have a watery stool, okay, so if you have a watery stool, what stage do you expect to see from that? Okay, you would expect a trophocyte stage. Okay, so a trophocyte stage. If the environment is watery, okay, or if the material is watery, you expect a trophocyte stage. But if the stool is semi-formed, okay, semi-formed, you would expect both trophozoite or cyst stage. But in form, okay, in formed specimen, formed FORMED, formed specimen, okay, most likely you will see cyst stages in that stool sample. So here we have, these are actually Amoeba histolytica. Okay, so they, in this part, so here, there are ingested red blood cell. So those are red blood cell. So undulating membrane, it occurs in flagellated forms of some organisms, which has a fin-like ridge along the dorsal area of the organism. Movement of this structure causes the body of the organism to undulate in wave-like movement. So there are actually two genus of amoeba, okay, which have the undulating membrane. We have the Trichomonas. Okay, so we have the Trichomonas hominis, vaginalis, and tenax, and aside from that, as well as the trypanosomes. Okay, so they have undulating membrane. Next slide. So vacuole, these are any of the various types of spaces, cavities within the cytoplasm of a protozoan cell. They may be used for storage. So in this image, the vacuole, so this is actually the contractile vacuole. There are also food vacuoles, and that is a pseudopod. Okay, so protozoan, we have different classes that is based on the locomotion that they use. So we have the Sarcodina, Flagellata, Sporozoa, and Ciliata. For Sarcodina, what is the organ of their locomotion? Okay, so that is pseudopods. For Flagellata, as the name implies, they use flagella. For Sporozoa, okay, nine. Okay, and for ciliata, they use cilia, of course. So under Sarcodina, we have the amoeba, and this is our main topic for this discussion. So we have the amoeba. Okay, next slide. Okay, so here we have the biodiversity of 4 subdivisions according to locomotion. Again, for amoeba, pseudopods, flagellates, eflagella, ciliates, cilia, and sporozoa, none. So as you can see here, we have this parasite. So this is actually a characteristic of the Georgia lamblia. Okay, so the Georgia lamblia uses flagella for locomotion, and the Georgia lamblia is actually has a name that is the old man with eyeglasses because of this characteristic or because of this feature. So old man with eyeglasses, that is Georgia lamblia. The former name for Georgia lamblia, that is the Georgia duodenalis. Okay, so next slide. So we have the possible life cycles for protozoa. Okay, so again, so there are 4 life cycles, possible life cycles for the protozoan. So we have here, so first we have the direct transmission. So when we say direct transmission, that is the transmission of trophozoites through intimate body contact. So when does that happen? Of course, that is during a sexual activity. And what are the possible or what is a parasite that can be transmitted through sexual interaction? So which is under protozoan parasite, we have the Trichomonas vaginalis. So for the second, we have the fecal oral route. Okay, so that is the transmission of environmentally resistant cyst stages pass in feces of one host and ingested with food or water by another individual. So, examples of parasites that can be acquired through fecal oral route transmission are we have Entamoeba histolytica, the Entamoeba, uh, Giardia, the Giardia lamblia, I should say, and the Balantigium coli. So when we say fecal oral route transmission, the infective stage is present in the feces of the infected individual. And when he passed that feces, like in the environment wherein it contaminates the soil, and this example, the soil is already contaminated by the infective stage. So children are playing in the soil, their hands get contaminated with the parasite because they are playing in the soil, and then when accidentally they bite their nails or their hands, so they ingest the infective stage. So that is a mode of that is fecal oral route. Aside from that, what if an infected individual just defecated and he forgot, wow, diba, nakalimutan, he forgot to wash his hands. And he was the person who prepared the food for dinner or for breakfast. Okay, so the infective stage was present in the feces or in the stool, okay, and it was accidentally ingested, okay. But guys, take note that you can only be infected if you ingested the infective stage. Like for example, for Entamoeba histolytica, again we have 2 stages, and what are those 2 stages? The trophozoite and the cyst form. And what is the infective stage for Entamoeba histolytica? The cyst form. Okay, so if you ingest the cyst form, you would be infected. But if you ingest the trophozoite, you will not be infected because the trophozoite is not resistant with the acidic pH of the stomach. Okay, so that is for fecal oral route transmission. Okay, for vector-borne, so in vector-borne transmission, the trophozoites is taken up by blood-sucking arthropods and is passed to new hosts when they next feed. Like in the case of what is parasite? It is a good example for vector-borne transmission. So we have the Plasmodium parasites. So that causes the disease malaria. Okay, so it uses mosquito. Again, what is the genus of the mosquito that can transfer or can transmit the Plasmodium parasite, we have the Anopheles species. But how about for dengue virus? We have the what genus of mosquito? Aedes mosquito. Okay, so for predator-prey transmission, that is transmission of zooids insisted within the tissues of a prey animal being eaten by a predator, okay, and subsequently shed spores into the environment. Example of protozoan parasite that has this life cycle RD is the Toxoplasma gondii. So if those spores are being ingested by cats, then they can be infected. And these cats, okay, can also infect a human being, most especially in pregnant women. Okay, next slide. So we're on slide 17. So most of the protozoan parasites reproduce through the process of binary fission. Okay, so in binary fission, like in this case, so we have this stage, you have the parent cell, okay, and then the DNA duplication happens. Okay, there is the division of the cytoplasm and you have two daughter cells. So that is for binary vision. And this is also the reproduction method for bacteria. Same with amoebas. But not all amoeba because for amoeba, they divide through the process of mitosis. Okay, so for amoeba, mitosis, entamoebas, and iodamoeba, they divide through the process of binary fission. Okay, so next slide. So amoeba. So that is slide number 18. So in amoeba, again, particularly the entamoebas, what is the infective stage? Cis stage. What is the feeding stage? The trophozoid. What is the motile? Which is motile? The trophozoid. What do they use for locomotion? Okay, the pseudopods. So they move by using their pseudopods. Okay, so we have the intestinal protozoa, the amoeba. So we have the Entamoeba histolytica, the spar, Hartmanni, coli, Folecki, Nana, and Buchli. There are extraintestinal protozoa, okay, that extraintestinal amoeba, okay, extraintestinal amoeba like the Entamoeba gingivalis, which is a commensal in the oral cavity, okay. So guys, take note, among this, okay, so among this, only the Entamoeba histolytica is pathogenic, okay? Only the Entamoeba histolytica causes a disease. So we regard that as a pathogenic parasite. So the Entamoeba dispar, okay, is morphologically similar with histolytica. Therefore, you cannot, okay, differentiate them or you cannot identify if that is histolytica or dispar, okay, in if you saw a cis stage or trophozoid stage which defines an entamoeba histolytica in the stool, you cannot say that that is dispar or histolytica unless you see that the trophozoite has ingested red blood cell because only the histolytica can do that. Okay, so they are morphologically the same. Okay, even for Hartmanni, it is morphologically the same with histolytica, but the Hartmanni is smaller in size. Okay, so it is smaller in size. So that is, go to the next slide. But how can you differentiate them? How can we possibly know if that is histolytica and dispar? Okay, so we can use, or Hartmanni, we can use the PCR methods. Okay, so we can use the PCR methods. Okay, we proceed to the next slide. So, amoeba stages, again, the trophozoite and the cyst. What is the infective stage for Entamoeba histolytica? The cyst stage. How about the infective stage for Acanthamoeba? The trophozoite stage. Feeding stage, that is the trophozoite. Non-motile, cyst. Motile, trophozoite. In Entamoeba histolytica, which stage can ingest red blood cell? Trophozoite. Which stage can you see, would you possibly see in a watery stool? Trophozoite. In a semi-formed, both, and for a formed stool, that is cyst stage. Okay, so trophozoite, that is the motile vegetative stage. It multiplies through binary fission. Okay, binary fission, and it colonizes the host. So as you can see here, guys, so the cyst has more nucleus as compared to the trophozoite, and the cyst is actually spherical. Okay, so the trophozoite can ingest red blood cell, that is Entamoeba histolytica. Okay, so the cyst, that is in the inactive form. Okay, non-motile, but that is the infective stage for Entamoeba histolytica. Okay, it survives the environment due to the presence of the cyst wall. So the cyst wall renders the cyst resistant to adverse environment. The cysts do not multiply, okay, because that is the inactive form. However, some organisms divide within the cyst wall. Okay, so Entamoeba histolytica being the only pathogenic entamoebas. Okay, so morphology. So I hope, guys, you don't need to memorize everything like the sizes. Okay, unlike before us, we memorized everything. Okay, before yun. But to help you guys, you don't need to memorize this one. The important factors here, or the important factors to consider in defining the different morphologies of the different entamoebas are of course, the motility is important. Okay, the number of nucleus, the peripheral chromatin, the chromosomal chromatin, and the cytoplasm, as well as the inclusion. It's like, ma'am, almost all except for the commensal, except for the size. But you don't need to memorize everything. Like for motility, motility of Entamoeba histolytica, that is progressive. What do you mean by progressive? It moves in a straight direction. Okay, diretso siya patungo sa kanyang pangarap. Okay? Char. Okay, progressive, it moves in one direction. Okay, so the nucleus of the trophozoite has only one nucleus. Okay, unlike for the cyst stage of the Entamoeba histolytica, it has how many? For the mature form, ilan yung nucleus niya? That is 4. Okay, so it has 4 nucleus for the cyst stage of Entamoeba histolytica and 1 for the Entamoeba histolytica trophozoite. So the peripheral chromatin is fine granules, usually evenly distributed and uniform. So actually this part, it's like the lining. So the peripheral chromatin, they are found on the lining of the nucleus. So it appears as fine granules. The chromosomal chromatin, that is the chromatin that is found either on the center or eccentric um, on the nucleus. However, for Entamoeba histolytica, take note of this one, they are usually central. Usually, nasa gitna po yung chromosomal chromatin. Again, the peripheral chromatin are fine granules and evenly distributed. For the cytoplasm, finely granular cytoplasm. Unlike for Entamoeba coli, that is coarse granular. Okay, so inclusion, possible erythrocyte or red blood cell, and of course, the bacteria. So we have here again stained specimens containing the trophozoite stage of the Entamoeba histolytica, wherein we have here one nucleus, and isa lang na nucleus. These two images, they have ingested red blood cells. So there. And aside from that one, they have central caryosome. So, nasa gitna yung caryosome. And the peripheral chromatin are fine and evenly distributed. So, I hope you remember those guys. Again, question. What are the two entamoebas that are morphologically the same with Entamoeba histolytica? First is Entamoeba dispar and the Hartmanni, which is smaller than Entamoeba histolytica. That is the Entamoeba Hartmanni. Okay, so we proceed. So the cyst. So the cyst, that is the infective stage, but the non-feeding stage. Okay, so the number of the nucleus, 4 in mature cyst. Okay, so 4 in mature cyst. The peripheral chromatin present is fine. Okay, same with the trophozoite, caryosomal chromatin, fine, central, located in the center of the nucleus. They have chromatoid bodies. Okay, so unlike for the, as you can see, unlike for the trophozoite stage, they do not have the chromatoid bodies or the chromatoidal bodies. But for the cyst stage, they have the chromatoidal bodies. And take note of the morphology or the characteristic of the chromatoidal body of the Entamoeba histolytica. For Entamoeba histolytica, okay, so they have chromatoid bodies. Take note of these words. They have bluntly rounded ends. So the ends of the chromatoidal bodies are rounded, okay, rounded ends. So glycogen usually diffuse concentrated mass often present in young cysts, which stains reddish brown with the iodine stain. So this is the cyst stage. So central caryosome, take note of that. So pathogenesis for Entamoeba histolytica. Okay, so we have here the amoebic colitis. Amoebic colitis displays the symptoms of abdominal pain, signs and symptoms with abdominal pain, diarrhea with or without blood, and mucus. Bakit possible na magkaroon ng blood sa stool sample ng isang individual that has amoebic colitis caused by Entamoeba histolytica? Guys, take note, histolytica. Okay, Entamoeba histolytica, it has the invasive form. Okay, therefore it can destroy tissues. Okay, so take note of this word. Histo means tissues, right? Histology, study of tissues. Histo means tissues. The lytica represents lysis. So the Entamoeba histolytica, lysis of tissues. It is capable of lysing the tissue. Okay, I hope that is clear. Another is, so the mnemonics, actually this one should be discussed in the last part, but I have introduced it already, so we'll discuss it now. So the ENT, okay, you can think of that as enterocyte. When we say enterocyte, those cells are found in the intestine. Okay, so the colonization of Entamoeba histolytica occurs first in the intestine, and this is an amoeba, so this is a protozoan parasite. Okay, histo for tissues and the word lysis, so this parasite can cause the lysis of tissues. Okay, going back to amoebic colitis. Okay, so colitis, when we say colitis, what does that mean? That is the inflammation of the inner lining of the colon. Okay, inflammation of the inner lining of the colon. So in children, there is a fulminant colitis. When we say fulminant, that is a sudden onset. So in children, there is a sudden onset of inflammation in the inner lining of the intestine with severe bloody diarrhea, fever, as well as abdominal pain. Okay? So, aside from that, we have the amoebic liver abscess. And this is the most common extraintestinal form of the amoebiasis or the amoebic dysentery. So, fever and right upper quadrant pain. There is the presence of fever and right upper quadrant pain. The right upper quadrant pain that is experienced by infected individual, that is actually the cardinal sign. Okay, so that is the cardinal sign of amoebic liver abscess. What do you mean? What do we mean when we say cardinal sign? Okay, in medical terms, when we say cardinal sign, that is the primary or major clinical sign or symptoms by which a diagnosis is made. Okay, so that is the primary or major clinical sign and symptom of amoebic liver abscess. So the liver is tender and hepatomegaly is present in amoebic liver abscess. What do you mean by hepatomegaly? That is the 3 to 1 enlargement of the liver. Okay, from the word hepa. Okay, so we have two forms of Entamoeba histolytica. We have the invasive and the non-invasive. Okay, the commensal histolytica, commensal Entamoeba histolytica, and the invasive Entamoeba histolytica. Among the two, which is pathogenic? Of course, the invasive form of Entamoeba histolytica. Guys, take note of this one. Okay, in the invasive process, the trophozoite stage penetrates through the